technology transfer activities. Knowledge generation, transfer, research results, and inventions. Just to correct the terms. Research results does not mean research results. It's just referring to the example of discover by assessing the amount of potential patents that are based on discover developments. So it's not research results as we typically understand it. Knowledge generation and transfer is a certain level of bridging, because when it deals with technology transfer, then in an organization, we typically have to face that the environment in the organization has to be innovative, or let's say innovation friendly. And of course, knowledge management is aiming at, to a certain extent, the creation of innovation friendly environments in organizations. And organizations means entities in all forms. This brings me to my overview. I will say some words on knowledge generation and the need of an innovation-friendly environment. Then I will give a definition of technology transfer and say some aspects on this. Some aspects is almost, let's say, an understatement. It's a bit more than some aspects. It's maybe also an attempt to visualize how the development of a product or a process goes along the entire route until it reaches the launch to market. So it's a bit more than some aspects. And then I will just focus on the example of Discover, in particular the Work Package 4, which I represent, or of which I am the Work Package lead, and say some word on inventions. And then I will conclude with the necessity on further relevant measures to promote a product. In other words, the aspect that there can be barriers that hinder you from promotion, from protecting and patenting a certain idea. And this is the barrier aspect. Yeah? And then I will summarize. Knowledge management is considered as a basis of sharing and using and managing knowledge of an organization, which is typically a multidisciplinary approach, because it makes use of an holistic assessment of the generation, maintenance, and further development of knowledge. And this is accompanied by the use of what people call knowledge management tools or innovation management tools that are often linked to the information and communication technologies that we have nowadays, very often, but not always. For example, a tool can also be a fully relational database on projects in a firm or in an enterprise. Yeah, this is also a knowledge management tool. Then, of course, the creation of knowledge for an organization and organizational learning. Organizational learning means, as it's written, the learning process of the organization. So it's not only assigned to individuals, but to the organization in itself. Then necessary levels of creativity and innovation within the organization, which is a needed enemy in order to be innovative, in a sense that people are prepared to develop ideas and to further develop them and to create this level of invention environment. Then the knowledge transfer, of which technology transfer is a subset. I will explain this later on, still more in detail. Also beyond the organization, which is the horizontal knowledge transfer and technology transfer. So there is, in principle, knowledge transfer can also be the transfer of a process, of a skill, for example, which is beyond of a pure technology transfer. Knowledge is difficult to measure and evaluate. The knowledge management provides some measures to do so. One known feature is what people call Tobin's Q, which is the balance of a market value of a firm against its book value, or let's say not the book value, but the assets replacement value. And there's one system that orders this in the world. This is the stock agencies. So for joint stock companies, this works. For example, you can observe that highly knowledge-based firms and stock companies have very high values of their stocks, of their values. For example, Apple or Alphabet. The market clearly assigns values that are far above the value the firm has on basis of its replacement values. And this is a typical feature of a knowledge-based organization. But this does only work at stock agencies. It does not work anywhere else. In other words, there's also other methods which are called inductive methods to measure knowledge. This is a monitoring of knowledge on basis of certain criteria, like the number of publications, the number of patents, the number of external scientists that visited your entity, and things like that, which you then follow on and write down over the years, and then you get trends. And on basis on whether a trend is good or bad, you can say, okay, this is a good relation, this is a good deal, or this is a bad development. This is how it works. I will show one example out of my research group, how this can be done, but only a public example. We still stay at high level, but we have to, because we have to talk about transfer and knowledge transfer. Well, this departs from the development of knowledge within an organization. And this stairs you see here is very well known. It was developed by a guy called North. I adapted it a bit. It's the knowledge stairs of North, and it explains how knowledge is developed. And the left lower part is, let's say, the boring part, which starts with character and data. Maybe it starts getting interested on the level of information for us. It starts getting interesting. And when you move this into knowledge, and now what's the difference between information and knowledge? Typically, if knowledge is generated in an organization, then this knowledge has to be oriented with respect to the core competencies of the entity. Yeah? In other words, we are in search for a certain thing. Imagine, for example, a review. If you do a review, you can collect a number of paper that are contained in your review, and then you can tag them together, and then you have the review. So you have a collection of papers. This is what typically would call a bad review. A good review uses the information in the papers and does a synthesis. For example, on basis of a scaling approach, for example, a firm could be interested in a certain level of turbine technology, for example, a certain size in power and geometry, which doesn't exist at the market yet. What do? You do a review, and then you do a scaling on basis of the existing designs that you find in literature. And this is then a synthesis approach, which then turns the information into relevant knowledge. But this is still descriptive. So it's lexicon knowledge. And lexicon knowledge does not help for a firm or an institute to survive. The institute needs procedural knowledge. In other words, action knowledge. The people need to use certain level of tools, and they need to know how to use it. And this is linked to the application. It's not sufficient to have heard 12 of lectures on finite element methods. When you enter a firm, it's rather sufficient to know a tool and to know how to run it. And that's the difference. So that's the procedural knowledge, which moves into a competence and competitiveness. So in other words, if you climb up the stairs further, this ends up in competitiveness and the further stressing and emphasis on the core competencies of the organization or the firm. Why am I saying that? I'm saying that because this is accompanied by what people call strategic knowledge management, because the strategy dictates to a certain level on what is assessed content-wise. For example, if an employee gets a training, it won't be a training in guitar playing if the firm does an engineering task. So it's oriented with respect to the overall context of the firm. And the operational knowledge management does a similar thing, but by making use of accompanying activities on the level of using tools that are knowledge-based, databases and things like that. In other words, this process of knowledge development is linked to an environment that has to be created, which is nice to creativity of people and innovation friendly. So this is let's say, a measure or tool to develop an entity into a friendly or into an aspect where they have an innovation friendly environment. In other words, creativity, I already mentioned it, it's not innovation, it's accompanied by aspects such as culture and environmental conditions within the entity and can be promoted by motivating aspects such as honor jobs, training, money, you get more money, coaching and mentoring, which is one element that also was established or implemented within Discover, and many other items. Then the identification level of the team, for example, via a knowledge management-based inductive derivation or evaluation of the knowledge base of the entity, meaning through success, through visualization of success, which then the employee or the doctoral candidate sees, and this makes him happy and proud. So we have a feedback, a positive feedback on its level of self-identification with the thing he does and his colleagues do. But knowledge is difficult to measure. I do that in my group. I have established 4 years ago what we call PWK ERA, which is the name of the group, Knowledge Management Monitor. And I only explain one example. And then I skip that and move to technology transfer, which I should have done earlier, but it's like it is. Anyway, what we do is We follow and look at the publications, the thesis, the networking of the dissertants. Where do they go to? Do they go to DLR? Do they go to NASA? Do they go to firms? We monitor awards that we get or people from us get. We monitor the patents. We monitor the project. We monitor the personal. We monitor the collaborations. And when you do this over many years, you can develop trends. And then you can tell people, oh, this works nicely. This doesn't work that nicely. We have to take measures to improve this. We have to take measures, knowledge management measures, to improve the friendliness towards innovation. This is what we do. And I'll show one example. This is the number of journal book publications of the group over the years. And you see it's significantly increasing. And you also see that the impact is increasing. And by monitoring this over many, many years, you can not only do predictions, but you can also take certain measures if you think that this number isn't high enough, for example, or if you think you have to do something else, or you can come to the result that you have to look at higher level journals because the impact of the journals used so far is too low, things like that. And you do the same for budget, patents, dissertations, student thesis, awards, networking, collaboration. And then you end up in a mess of work. But when you have established this once, you only have to adapt the numbers and the figures and the names in the following year. And then you have it. We've made great experience with that. It really positively feedbacks to the people that are involved in the team. And this was this aspect. This comes a bit late, technology transfer. How is this defined? It's the process of transferring technology from a person or an organization that owns or holds it to another person or organization. In other words, it deals with the technology transfer in between universities, businesses, governments, across borders, formally and informally, openly and secretly. And what do you share? You share technologies, samples, or even facilities, or facility designs. It's closely related to another term which is called knowledge transfer, but knowledge transfer is a bit higher in level because it also includes the transfer of skills. We consider horizontal transfer as the movement of technologies from one area to another. So at present, technology transfer is primarily horizontal or considered horizontal. But there's also vertical transfer, which is technology that are moved from applied research centers to R&D departments and vice versa within one organization. Technology brokers, let's skip that. And technology transfer can involve dissemination of highly complex technologies that are also linked to a certain need of the investment of capital. But also it can be the transfer of appropriate technology, not necessarily at high tech or expensive. This is this aspect that many people often have when they see a pattern and say, oh, it's so easy, why didn't I have this idea? This aspect is for sure of a value. In our world, we have to realize that there's this development path from an idea to a product or a process. And the first measure is to say, this is linked to TRL. And I'm just saying that. I'm saying it's linked to TRL, and I'm saying use the TRL as criterion, meaning that research tends to be focused rather on TRL 1 to 3 and 3 to 6, the latter often in a collaboration with industries. And the readiness for production focuses on the higher TRLs between 6 and 7 and higher, which is typically performed within industrial entities. There are, of course, exceptions. And the experience is that bridging TRL 3 to 6 has proven to be difficult. This is understandable because if this entity was rather something like a research institute or universitarian research institute, then it's exactly the gap this institute can have by rather focusing on theoretical and technological approaches, feasibilities, than products. So if you attempt to rush research into production, then this is of course costly and time consuming. And one major problem is the funding schemes. And I learned that these funding schemes that bridge an idea and a patent to a product are very, very individually treated throughout the entire different countries in Europe. There are countries in Europe that have certain measures and such measures, and there are countries in Europe that don't have this, which is a difficulty for the guys who are in this country, of course. This is not the full story. The full story is shown in this diagram. It looks a bit ugly, but let's try to understand it. It's a well-known diagram, which is coming from a guy called Specht, but I modified it strongly. I overtook the boxes, the yellow boxes, and then I added some things. What Specht did was to order these development paths from an idea to a product or a process that has to be launched into a market, which is nice. The important thing is to correlate this with the TRL. So when you look at the TRL, then you can definitely say that the first 3 yellow boxes are rather limited or oriented to lower or moderate TRL of up to 4 or 5 maximum, while the latter TRL is moving into the product and process development rather. At the end of the day, it also means that the activity per se in which for example, the university is involved is very often limited to TRLs that are lower or equal than 6, which is marked by the gray bluish box. So this is very often the university's maximum range. Of course, there are exceptions. We even ourselves made such exceptions once upon a time with ESA in a project. And then the yellowish box, of course, signifies that this is limited or that this necessitates the support from it. In other words, you have a trade in between the protection of your idea, which will have to be protected very early, in other words, at low TRL, and the liaising with industries that is a needed enemy in order to be able to accompany further development at higher TRLs, because this is where the industry is needed. So there's a certain trade. I also marked this green arrows saying R&D management, technology management, and innovation management. I don't define them. All I will say is that technology management is typically a subset of R&D management, and R&D management is a subset of innovation management. And innovation management, by the way, is a subset of knowledge management. But this is the situation in which we are. And if we consider this, we have to find ourselves in an assessment, firstly for Discover, because Discover is a FET, and FETs definitely aim at conceptual ideas and ideas that are at low TRL. In other words, they can be the ground, the basis for the birth of a group of ideas along the entire project phase that are capable to be protected or patented. The use of the TRL demonstrates the needed timing of a patent. So experimenting with an invention does not block patentability, but using an invention in public or in a commercial context can block IPR, and this leads to the fact that patent applications should be filed at low TRL, which is exactly the position and the situation in which Discover is. But there's a trade, there's a risk balance. One moment, I have to move away the videos from here because I don't see the slide. There's a risk balance between patenting a thing at too low TRL and patenting it at a too high TRL, as you can imagine, because when you do it at a too low TRL, you of course guarantee that nobody else will take the idea, but you also risk that you aren't adequately done with the feasibility. Yeah, so there's a certain risk along with that. So the product development, as I already said, and the launch to the market requires both industry accompanying it and relevant funding schemes promoting it, which can be difficult. So you have to establish an early liaising and exchange and networking with relevant industries, which can be started and maybe should be even started from TRL3, despite of the fact that our yellow boxes that we have seen before still can be coped with by the universitarian industry without the real support of the industry. But you have to mitigate the risk, so you have to liaise quite early. Some inventions, but polemic inventions. Total internal reflection was patented by Wheeler in 1881, and the fiber optics came 90 years later. The theory of lasing from Einstein came into place in 1917, but the first prototype laser came 43 years later. Now with X-rays, it was different. With Röntgen rays, it was different. Röntgen found them, I guess, in 1895. And in the early 1900s, there was already systems that were used for medical profession. Why I'm saying that? Well, there are also other things where you can motivate the need of a product. One example for this is radar. It took 35 years with nothing happening after the patent from 1914. And then we had a world war and money, and then we had it some 2 or 3 years later in the 1940s. So the speed to market or the need can precede the product, and the speed to market dictates success or failure. And now the other extreme, if you are at typical developments, for example, in the field of consumer electronics, then this time to market is less than 1 year. So they're quite fast. maybe a bit too fast for us. But it explains now why I always ran into trouble when I had an idea and tried to patent it and ask industries, and they negotiated, you have to do it in 2 years, then we follow you. And you said, I need 4 years or 5 years. And they always said, no, 2 years, 2 years. Now I understand it. We have to be really quick with the time to market. But 1 year maybe is too low period of time for our purposes, I guess. In Discover Package 4, Claire and Peter identified a number of ideas that have a certain level of potential to be patented. And it turned out to be that they developed 7 ideas together with us, out of which some of set of those ideas is really, let's say, has the potential to be patented. But it's quite a lot. It's more than we would have expected, I would say, when we started the project. 7 is quite a lot. And I think within the entire Discover, we have definitely more than 10 ideas that have a certain level of potential to be patented. But of course, you then do research. I did that, for example, for the Helicon thrusters, and found that there's the Helison type plasma source, but there have already also been established 2 new patents from China, just in these days or 1 or 2 years ago. So there are already patents, and the Chinese patents definitely emphasize or stress the application of electric space propulsion. So the patent presumably is gone, but it's not really gone, because the law, the patent law, allows us to do certain things. For example, a universitarian institute can at any time improve a patent, and when the design is definitely improved, you can even launch a new patent with the improved design. You can do this as long as you do not anything harmful to the market constellation. In other words, when you test a new design and develop a new design, you have to do it in your lab without somewhat linking this to commercial aspects. And when you're done, you can patent it from the new with an improved design. This is allowed. Patents in general can lead to several types of benefit. One benefit is licensing fees. In other words, you are a university, for example, you have a patent and an industry uses the patent, and you correlate this with a certain payment per each product that is sold on this basis. I do not know what with the others is. We have this constellation currently within a component development project with DLR, with a firm in Stuttgart. Another way of doing it is you get budgets from selling a patent to an interested entity. This can be even a patent that is shared between 2 entities where one of the 2 sells it as part to the second. This is what we have just done with a patent back in April. And we got the money for it. And the law even organizes and demands that the individual inventors have to get a certain budget out of this, namely 30%. I do not know how this is in other countries, but in Germany, it's a 30% out of this. So the 2 inventors in this patent got even money for this. And patents are part of the knowledge database of an organization, which feeds back to this endless and quite action learning related presentation part before that we had before. Anyway, but we have to consider that there are barriers for patents. It's very nice when you look into publications, for example, the one from Hamadi and Kretzig, which I more or less copied here because this publication was a poster they presented at one of the battery development conferences in Germany. And in principle, they did an inquiry and found that the most salient weaknesses are communication between scientific research and industry and lack of mutual trust. What does this mean? At the end, it means that the process from an idea to a product or a process can suffer from barriers. And these barriers can be at different levels. They can be on an acceptance level, they can be on a knowledge level, they can be on administrative level, and it can be on the level of the corporation. And what they say, okay, use promoter. And now you say, okay, then you have power promoter, the expert promoter, the process promoter, and the relationship promoter. You can also express it negative. Negative expression would be, a guy like me, for example, Georg Hartwig, has a colleague who is the director of the institute. And the director of the institute would be the power promoter, or the one who likely opposes it for certain reasons. In other words, you have to create this to come to the point of patenting with a minimum friction. This is in principle what this study from Hamadi and Kretzig, Lecker and Zig is saying. In other words, you have to minimize relevant barriers, and you have to may find people that are specialized in mitigating these barriers, which are called promoters in this study. What's the summary? Successful technology transfer needs adequately motivated environment and strategy. A network of trust is needed within the concerned entities, in other words, promoters. The environment and strategy can be continuously improved, making use of knowledge management-based tools. Depending on the entity's branch and size, these tools need not be that complex. Yeah, I mean, a firm with 5 people won't be developing a relational database on projects, yeah, because this would occupy 2 of them, and then the firm would run out of money. Discover, interesting enough, has achieved this successfully via the innovation management-driven measures that were taken within the conditions that a consortia project as such has. Examples are the mentorship and the relevant innovation management approaches that were done within the activities of Work Package 7. That's all. Thank you.